Welcome back to the deep dive. Today we're tackling a really common problem, actually. How do you get truly reliable, super fast internet when you're, way out there?
Right.
Miles from any cell tower. Thinking maritime operators, remote teams, even yacht owners.
Yeah, it's a big one.
We've been digging into a bunch of sources all about the Starlink ecosystem, focusing in on the Starlink Mini system, and critically, the strategies people use to keep that connection solid out at sea.
That's right. And these sources, they really lay out a roadmap for anyone who needs that constant high bandwidth connection for real operations, not just checking email.
Right.
We're basically talking about going from zero connectivity to proper high performance internet offshore.
Yeah.
So our mission today is to pull out those practical technical nuggets, how to really maximize LEO satellite performance, and this is key, how to build in redundancy. So a signal drop doesn't completely derail everything.
Okay, sounds good. Let's start with the hardware that really takes the beating. The Starlink Mini Mount. It seems kind of basic, maybe, but the sources really hammer home that this mount is foundational for digital stability. What's it actually doing? What problems is it solving out there in the harsh maritime world?
Well, it's primarily solving stability and corrosion. Your standard mount just isn't built for constant movement. Yaw, pitch, roll, plus all that salt spray and wind. It's incredibly corrosive.
Yeah, brutal stuff.
Exactly. So the mini mount, it's engineered specifically for that operational challenge. It has to keep the antenna stable enough to track those satellites accurately, even when the vessel's moving all over the place.
And it seems pretty versatile, too. The sources mention it works for yachts, commercial vessels, mobile setups, and you can mount it flat or with a wedge or even on a pipe.
Yeah, that versatility is crucial. It lets you find the best spot to maximize that all-important line of sight to the sky, and it makes the whole installation process, less of a headache. And that flexible mounting works hand-in-hand with the Starlink Mini antenna itself, which is, compact, lightweight, but it still packs a punch in terms of speed.
How much of a punch are we talking?
We're seeing peak speeds, according to the sources, up to 250 megabits per second.
Wow, okay. From that small unit, that's genuinely game-changing for working offshore. Supports HD streaming, video calls, proper remote work.
Totally. It really redefines what a remote office can be. And a big plus is the plug-and-play aspect. It's designed to be much easier to set up and more dependable for, let's say, non-expert users compared to older satellite systems.
Makes sense.
And we should remember, the Mini is just one option, right? Starlink also has the flat-panel high-performance antennas, the Gen 3 high-performance. They're all built tough, designed to handle vibration, wind, changing temperatures at sea.
Right, so you've got options depending on the need. But okay, having great hardware is one thing. The performance really hinges on the network it connects to. This brings us to the core tech advantage, LEO satellite connectivity. What is it about LEO that blows the old maritime solutions out of the water?
Okay, so let's define terms quickly. Traditional marine satellite internet, that used GEO satellites.
Yeah.
Geostationary.
Right, the ones that seem to sit still in the sky.
Yeah, because they're parked way out there, like 22,000 miles above the equator. That huge distance creates massive lag, high latency.
Ah.
The LEO satellites, low Earth orbit, they're zipping around much, much closer, just a few hundred miles up.
So the aha moment is just proximity, shorter distance, less travel time for the signal.
Exactly. That drastically cuts down the latency. And low latency isn't just nice for Netflix. It's critical for operational stuff. Real-time navigation updates, remote diagnostics, instant comms.
Things where lag is actively dangerous or costly.
Precisely. And another piece of tech the sources highlight is phased array technology.
Okay, let's decode that. Why does phased array matter on a boat that's constantly moving?
So phased array antennas don't have moving mechanical parts to track satellites. Instead, they steer the beam electronically.
Ah, clever.
Yeah. On a stable roof, a normal dish works fine. But on a pitching, rolling vessel, you need something that can steer that beam instantaneously without physical gears and motors. That's what maintains the strong, continuous link to those fast-moving LEO satellites. It's really what makes high speed possible in motion.
That makes perfect sense. Okay, so recap. We have robust hardware, stable mounting, tracking fast, low-orbit satellites electronically. Sounds pretty reliable already, but even the best network can have hiccups, right? Little dropouts. So, Section 3, how do you make this connection genuinely bulletproof for those times when you absolutely cannot lose signal?
The key insight really is redundancy. Never rely on just one connection type. The strategy highlighted again and again is combining marine satellite internet like Starlink with your traditional LTE or 5G cellular networks.
Like a hybrid approach.
Exactly.
Okay.
Think of it like a boat with twin engines. If one have an issue, the other keeps you going.
So Starlink handles the deep offshore stuff where there's no cell signal.
Right, the long reach.
And then LTE or 5G kicks in closer to shore or in port, offering maybe even faster speeds or lower latency.
Yes, you get dual connectivity. And ideally, the system switches automatically between them based on which signal is stronger or better performing.
Okay, but seamless switching. That sounds easy to say, but isn't blending two totally different networks, satellite and cellular, tricky? Don't you risk dropouts or buffering during that handover?
That is the critical question, isn't it? You can't have your connection stutter mid-video conference or during a critical data transfer.
Definitely not.
And that's where these network optimization tools come in. The sources mention the concept of a signal optimizer, or sometimes called a blender. One example given is the MDS Blender.
A blender. Okay, what does it do?
It's designed specifically to merge multiple network connections like Starlink and LTE 5G into a single, stable, logical connection for the user.
So it's like an intelligent traffic manager. It smooths out the transition, picks the best path for data, and keeps the connection continuous even as you switch between satellite and cellular, reduces downtime.
Exactly. It creates one reliable data pipe from two potentially fluctuating streams.
Yeah.
This moves beyond just having two separate connections to having intelligent automatic redundancy.
That sounds powerful.
Yeah. And as a sort of real-world example, the sources mention things like the Romeo Foxtrot Starlink bundle.
Okay, let's use that as a case study. How does it pull all these pieces together?
Well, it's basically a pre-packaged, comprehensive solution. It might combine, say, dual Starlink high-performance antennas for more bandwidth or failover, plus a sophisticated router like a Peplink Max BR1 Pro 5G to manage everything, and crucially, that network blending technology.
So it's built for maximum uptime, not just speed, for those really demanding maritime operations.
Precisely. Total coverage reliability.
Okay, so you've got this bulletproof digital connection sorted, but it's all for nothing if the physical installation fails, right? Especially at sea. Let's talk practical how-to. What are the absolute must-dos for installing this stuff so it lasts?
Yeah, installation is critical, especially on a moving vessel. It has to be meticulous. First, obviously, choose the best spot flat or wedge mount surface. Secure it properly with good quality hardware. Second, that line of sight we mentioned. Absolutely clear view of the sky, no masts, other antennas, structures blocking it, even partially. That causes intermittent grief.
Makes sense. And you mentioned something specific about movement earlier.
Yes. This is super important for marine installs and often missed. You need to align the antenna installation relative to how the vessel typically moves. You want the mount placement to help counteract the boat's natural motion, not make the tracking harder for the antenna. If it's in a spot that whips around wildly, performance will suffer.
Right, thinking about the physics of the boat's movement and safety with electricity and salt water?
Absolutely critical. Proper grounding is non-negotiable. And careful cable routing. You need to protect those cables from chafing, vibration, water ingress. Sloppy cabling will fail in rough conditions or due to vibration over time.
Okay, installation done right. What about keeping it running? Long-term maintenance? Saltwater just eats everything eventually.
It really does.
Sure.
Routine maintenance is the only defense against unexpected failures. You need a checklist. Regularly clean the antenna surface salt buildup definitely impacts performance.
Just hose it down.
Gently, with fresh water usually. And critically, inspect all the hardware. Look for any signs of corrosion on the mount, the fasteners, connectors, even marine-grade stuff needs checking.
Catching rust early.
Exactly. And check connections. Tighten any bolts or screws on the mount that might have vibrated loose. Vibration is relentless at sea.
Good point. Easy to forget until something stops working.
Right.
Right.
And finally, the software side. Keep the firmware on the Starlink dish and any routers updated. Those updates often have bug fixes, performance improvements, better tracking algorithms. Really important for reliability.
Okay, that's a solid maintenance plan. So we've covered quite a journey here. Started with the really robust hardware and mounting built for the sea. Then the tech leap with LEO satellites, low latency, phased arrays, and then making it bulletproof with redundancy, combining satellite and cellular using smart blending tools.
Yeah, it's that integration, that intelligent blending that provides the real resilience. The whole system, when done right, ensures those critical comms stay up and stable, even way out in challenging conditions. It really just raises the bar for what's possible with maritime connectivity.
Which brings us to a final thought, something for you listening to maybe chew on. If you have consistent high-speed internet at sea, reliable enough for real-time operations, remote management, essentially turning a ship or a platform into a genuine mobile office. Well, this tech isn't just about communication anymore, is it? It kind of dissolves the whole barrier of distance.
That's a great point. And it prompts a big question. In a world where high-speed satellite internet becomes ubiquitous, how do industries like shipping or ocean exploration or even large-scale fishing fundamentally change how they operate? With real-time data, remote decision-making always available, those old geographical limits on managing fleets or operations centrally, they're just vanishing. It forces us to rethink what being at sea actually means for business, for efficiency, for how work gets done.
A fundamental shift. Definitely something to think about long after you've left the shore.
Yeah.
Thank you for joining us for the deep dive.